All right, welcome to part 2. We're going to be talking about iterators and vectors today. So, vectors are one of the single most used data structures in the world. So, what is a data structure? A data structure is like something that holds a lot of variables. How about that for a technical term? Okay. So, a vector, like you don't, instead of making like 1,000 variables, you just make a vector of size 1,000. Boom. There you go. Okay. And the most common one, the number one data structure is vectors. Okay. The number two is something called a hash table. And we'll be learning that later in this semester. Between those two, that covers probably 90-95% of everything you need to know in computer science. Next semester is CSI 41. CSI 41 is called data structures. We're going to learn a lot of data structures, but you know what? These are the two that we use. And so today we're going to be going into depth on vectors and something called an iterator. Okay? So let's get to it. We can make a vector of integers named vec, and we can initialize it with some values, 10, 20, negative 30, 40, whatever, like that. Okay? And so this is a vector of size 4. It's got 4 values in it. And we might want to do something like print it out. Now, you guys should know how to print it out by now. We could say like cout starting vector, this, and then say for every integer x in the vector, cout x, like that. And that'll print 10, 20, negative 30, 40, right? Okay. So that's how you print a vector, right? So that's something important. Print a vector. You cannot see out a vector, unfortunately. You can teach C++ how to see out a vector. But if you want to print out a vector, that's kind of the one-line way of doing it. For every integer in the vector, print out the integer, done. Okay? Easiest way to print out a vector. Now, what if we want to do something like find the minimum element? All right. What if we wanted to find the minimum element in a vector? Well, what we could do is something like this. Integer min is equal to vector dot at 0. So we'll start with it equal to 10. Right? And then we could say for every number in the vector, if that number is less than the smallest one we've seen, then the smallest one we've seen is that number. And then we print the number. Okay. So do you guys understand what's happening here? So let's say, let's take it one at a time. The first time through the loop, x is 10, right? Because this is a for each loop. For each element in the vector up there, you can see it's 10, 20, negative 30, 40. So the first time through the loop, we set the minimum element to be 10, and we then start the for loop. So the first time through the loop, x is 10. Yes, we are repeating 10. No, I don't really care. I'm on a 4 gigahertz CPU or something like that. We can do an extra comparison. Who cares? So is 10 less than 10? What do you guys think? Is 10 less than 10? The first time through the loop, x is 10. And then we're going to say, is 10 less than 10? Nope. So what do we do? Nothing. Move on. Next time through the loop, x has what value? Second time through the loop, x has what value? 20. Very good. Is 20 less than 10? Nope. Next time through the loop, x is equal to what? Negative 30. Is negative 30 less than 10? Yes. So the smallest number we've seen changes from 10 to negative 30. Last time through the loop, x has what value? 40. Good. And is 40 less than negative 30? Nope. So what does it do? Nothing. And then it will print out the smallest element in the loop is negative 30. Does that make sense to you guys? Smallest element is negative 30. Okay. Now, I'll tell you that rather than doing all of this stuff here, there is a one-line function in stud that does the same thing. For lab time, do it. Okay? So in the standard library, there are common tasks, things that we do a lot. Finding the minimum element of a vector is one of the common tasks we do. And so your assignment during lab time is to hit up cppreference.com and find it. And cppreference.com has sample code. Use the sample code to put into this lab time code here, code that will essentially do the same thing as these 3 or 4 lines here, do a one-liner, okay? And in order to understand that, what's happening though with min element, we have to talk about something called an iterator. So, and be careful with the iterator it returns. So what the hell is an iterator? Learning point for today. An iterator is the address of something in the vector. Okay? So like if I were to tell you guys where I live, I would tell you I live at 1234 Main Street because that is 100% legitimately my address in real life. And so if you wanted to visit me, you would look up my address and go there, and then inside of that address you would find me. Okay? And so these things called iterators are the address of things in a vector. The most basic iterator I could think of is like the beginning of it. And so this is an iterator pointing at 10. It is not 10. If you try couting the iterator, it will not compile. Okay? You cannot print out an iterator. There's no cout ability for an iterator. This is not the value of 10. It's 10's address. It's like, my name is Bill, but my address is 1234 Main Street. Right? They're two different things. And so this is the address of 10. If you want to get the value at that address, use the star operator. Print the name of the person living in that house. That's what it's saying. So that star there, you're going to need that for your lab time today. Because there's a function that will find the minimum element for you, but it returns an iterator. It returns the address of the smallest element, and you have to use the star operator, the unary star, the dereference operator, to actually print the smallest value in the vector. So you can do it by hand like this, but I'm going to have you look up how to find the name and then how to actually do it using the standard library. Because in the standard library, you can do it in 1 line instead of 4. The standard library is like a superpower for you. Like that's what separates out new programmers from experienced programmers. Experienced programmers know what's been done already, and then they're just like, yeah, I don't sort a vector ever. I call sort. and that's like what most experienced programmers tell you. Like, yeah, sure, we all wrote like a sort function like back in CSI 40 or whatever, but hell no, we don't do that by hand anymore. Like, forget about it. And so a lot of standard library functions take what are called ranges. And so learning point, I guess I should do them in all caps. Learning point number 2, a range is a pair of iterators defining the start and end of the algorithm. So for example, if you wish to sort a vector, there's a function called sort. And if you want to sort the entire vector from beginning to end, you sort it from vector.begin to vector.end. This is how easy it is to sort an array. Okay, that's all it takes. You just call sort. What part of sort do you want to sort? From the beginning to the end. Okay, cool. And so vector.begin is the address of the first person in the array. Vector.end is not the address of the last person in the vector. It's actually one past the end. And the reason for that is, there's several reasons for it. Basically, vector.end is 1 after 40. So like vector.end would be like here. That's like where vector.end is. It's that address in memory, wherever that is in RAM. And the reason for that, do you need to include algorithm? Yeah, you have to include algorithm. The reason for that is like, what if you're calling find? So there is a function called find, and you're going to search from vector.begin to vector.end for the value of like 20. Okay. This will return pointing at 20. It's going to return an iterator pointing at this element right here. Okay. Oh, we've already got it. Okay, all well and good. And if we want to print the value of 20, we can do that. This will print 20. So find searches through the vector trying to find 20. And if it finds it, it has a pointer pointing at the thing. And then if you do that, it will print the value of 20. Now, what if you can't find it? What should the iterator be pointing at? Well, as it turns out, it returns this. It returns vector.end. So if we say if it equals vector.end, cout 20 was not found. Otherwise, print out the value found. It's not valid C++. Okay. So there has to be like a special spot right here that it can return if the thing wasn't found. Because like think about like what if they found 40, right? If you just return if end was that guy, then how do you know if it actually found 40 or if it's saying I didn't find 40 if you're returning a pointer to end? So there's this special weird sentinel value off the edge of the vector that is like where vector.end points to the address to the right of 40. Okay. And so that's how you can tell if something was found or not. You call find and you search for whatever value you're looking for. And then if it was found, it has a pointer to it. And if it was not found, then it returns end. And so what you're going to do for lab time, use this iterator and it to erase the value from the vector if the element is in the vector. So maybe we'll do something like this where we say like int value equals read. Please enter a number to search for and delete. Okay. We can do this after we print the vector, I guess. Okay, so what you're going to do during lab time today is you are going to use this iterator. There is some function in the standard library called erase. And erase takes an iterator. It takes the address of the person that wants to be deleted from existence. Or maybe it doesn't want to be deleted from existence. I don't know. It could be a hostile deletion. I don't know. So if you want to delete -30 out of the vector, then you type in -30 from the keyboard here. Oh, we need to. So it's going to search for value. Yep. And so if the user types in -30, it's going to return an iterator pointing at -30 here. And then your code that you have to write, not me, you're going to write it, will erase -30 out of the vector. If it is not found, then just print out it's not found and just move on with your life, okay? So this is code to find the minimum element. Then you're going to find the standard library function that finds the minimum element. And that code, just like with find, it returns an iterator. So the code that returns the minimum element returns an iterator. So if you want to print it, you have to do this instead. Okay. So rather than vector.begin, you're going to call some standard library function that returns an iterator, and then you're going to print the smallest value like that. And yeah, that's pretty good. And then sorting, right? So so most of these standard library functions take a range. They take a pair of iterators, where to begin, where to end, and almost all the time, not all the time, but like almost all the time, it's going to be from the beginning to the end. What range are we going to search for, you know, the value 30 in? The whole thing. What part of the vector are we going to sort? The whole thing. Okay? So most standard library functions take a range, and almost always it's going to be the beginning to the end. And then that will just sort the entire thing. Okay? And so let's just print the vector again. So let's search for and delete 20. Okay. So the smallest element in the vector is -30. The ending vector is -30, 10, 20, 40. Wait. Yeah, erase. Right. Yes. So yes. We didn't erase it, did we? No. You're gonna erase it. It just printed 20. Okay. 20 will be erased after you erase it. It's like, wait a second, 20 is still in there. Yeah, that's your job. Make the code work. I was shocked for a second. I'm like, I thought you were dead. Rumors of my death are greatly exaggerated. Okay. So do you guys understand what you have to do for lab time? I will put up this code here. Copy foo.cc. Wow, there's a lot of foos in here. Okay. Into the public directory. And so you guys are going to copy from /public/foo.cc into your current directory. I'll put this into Discord for you. It sorts from least to greatest. Yeah, you can have it sort backwards, but that's a topic for another time. So copy that code into your directory, and then you've got two different things to do during lab time. The first is to find the standard library function to erase, and the other is to find the standard library function to find the minimum element. Okay. cpp.reference is your friend. Okay. So use cpp.reference, see if you can find the code to erase from a vector, and it will give you demo code, and you can use the demo code, copy and paste it like we all do from cppreference.com. To erase from the vector, and then do the same thing for minimum element. And I'm going to give you guys like an hour to do this. If you finish this, then work on deal or no deal. If you have any questions about deal or no deal, let me know. We'll come back at 4:10, and I will give you the answer to this, and then I'll give you some tips on deal or no deal as well. Okay? Deal or no deal requires you to know vectors, maybe erase. That might be useful. Maybe when you open a box, it goes away. Maybe. Do you guys understand what you have to do for lab time? Look up code, plagiarize. Yeah. Plagiarism is the basis of computer science. So copying code that other people did, but making sure that it works. If you copy code and it doesn't work, like during the competency exams, a bunch of students like copying and pasting code to like find out if something's a prime number. Nope, that was wrong. Your job was not to find a prime number at all, really. But people were just copying and pasting blocks of code from the internet. That's the wrong kind of plagiarism. That's the kind of plagiarism we don't want to see. We want to see the plagiarism that will actually result in your code working correctly. So you have to understand enough of what's going on to even be able to plagiarize it. Okay? So there's your lab time, foo.cc. If you have any questions, let me know. We'll come back at 4:10 and finish the, give you the answers here, and then talk about deal or no deal a little bit. And there's no class next Friday, so you'll get a long Columbus Day weekend. All right, pausing the recording now. All right, it's 4:10. Let's resume. So, please enter a number to search for and delete. Okay, so we did a find, and we were given a iterator pointing at it. Now, What did you guys find on CPP reference? What is the name of the function to erase something from a vector? Anyone tell me? Did you guys were you able to navigate cppreference.com? What do you got? Yeah, erase. Okay. So we are going to say vector.erase, and then we just pass in the iterator. Note that we're not dereferencing it here. We're not saying, erase the value 20. We've got an address, and so basically what we do is we just creep up in our car, we roll down our windows, we say, all right, go to 1234 Main Street, shoot everybody inside, clean up after ourselves, drive off, circle back one more time, and then jet.
Hey, Kearney, your stream is not currently on the correct page.
Oh, it's not. Okay. So at least I'm not muted this time, right? How about now? There we go. Okay, so this is it. So you just need to erase whoever is at this address. Okay. If you want to print who's at this address, use the star. If you just want the address, their street address, 1234 Main Street, you just use the iterator. Now, some of you were trying to make a variable of like type iterator. That's actually not the class name. Okay. So just use auto. Make life easy on you. The actual class name is kind of stupid. So that's it. And then that'll erase something out of the vector. Maybe that'll be used for deal or no deal. I don't know. Maybe it will, maybe it won't. You might have to be careful if you're using it to not screw up the indices of your boxes. All right. So then for min element, did anyone find the name of the function to find the minimum element of a vector? And again, like I said, STDs are like your superpower. Okay, so when you're coding for real in real life, you can either sit there and re-implement sort from scratch and min element from scratch and a vector from scratch and all these things from scratch, and you just waste your time doing stuff that nobody cares about, that's not productive because it's done for you. It's in STD. Okay, all the stuff's in std. It's in standard library. You don't need to repeat yourself. I'll repeat myself. You don't need to repeat yourself. Okay. So yes, the name of the function is called min element, and min element also returns an iterator. And we're going to search for the minimum element from the beginning of the vector to the end of the vector, just like that. So again, an iterator is just a pointer, so to speak, to, it's not actually a pointer. A pointer is actually something a little different, but conceptually it works the same way. So we're saying from the beginning to the end, search through the whole thing, find the minimum element, and return an iterator pointing out which spot in the vector is the smallest one. And then if we want to say what the smallest element is, just copy and paste that, and we can just start it. Okay, so that is a one-liner. Actually, we could probably make this even more compact. There you go. There's a one-liner. So the min element function returns an iterator, and then we dereference the iterator to get the value at that address. And so most people that try using this, they forget the star, and they try doing that, and it doesn't compile. The reason why it doesn't compile is you can't see out an iterator. So you reference the iterator that gives you the value of the smallest value in the whole vector. So there you go, one line of code instead of 4 or 5 here. Yep. And it's like that with a lot of things when it comes to std. You could write your own sort function, but it's probably going to be slower. It's probably going to be buggier, and it's going to take a lot more of your coding time to write your own sort function rather than just using std : sort, right? So std : sort is the name of this algorithm. We of course are using namespace std, so we don't need to write that. But basically, std, the standard namespace, has a whole bunch of stuff in it for you, and the more you know that's in there, the more you can use stuff that exists and not repeat writing, a sort algorithm for the 900 millionth time in human history. People have written sort algorithms before that work pretty well, that are pretty fast, that are pretty bug free. Especially when you're like a first or second semester computer science student. If you were to write your own sort, it would probably have bugs in it. And the standard library probably doesn't have bugs in it. I'm not saying I've never found a bug in the standard library, because I have, but it's very rare for you to actually find a bug in the standard library. Okay. So that is our lab time for today. I hope you guys got a little bit of an appreciation for it. Basically, vectors are just the vanilla ice cream of data structures. Anytime you need to hold a lot of data, people typically will just start with a vector. And then if they need to, they'll use a more specialized data structure, but they're just so easy to work with. There's a ton of functions. You can find min element, max element, min and max element at the same time. You can sort them. You can shuffle them. If you want to see how to shuffle them, that's sorted vector is here. And if you want to shuffle it, you can just call like random shuffle. And there you go. That's all it takes. Nope, it doesn't sort the vector. It does the opposite. It shuffles the vector. Okay. Every day I'm shuffling, right? So there we go. And we run it. Who do we want to delete? We're going to delete 20. And you can see 20 is no longer in existence. We did a drive-by, took out 20. Smallest element left in the vector is -30. We sort it, and then we shuffle it, and you can see that they are now in a random order. Okay. And that's just how easy it is when you know what you're doing. When you know, and it's not even like it's honestly harder to write your own shuffle. You know, like it's a lot easier. It's a lot lower skill level to just call shuffle, right? Like this is just one line of code that you just spit out. Like there you go, shuffle. What part of the vector do you want to shuffle from the beginning to the end? Okay, done. That takes a lot less skill, takes a lot less intelligence, a lot less brain power, a lot less time, a lot less debugging time. Also, you just one line of code and you're done. And you're moving on with your life. And so you get to spend your time writing code that's interesting and fun, rather than like repeating the same code that has been written by a million people throughout, history. Back in caveman days, they were writing sorting algorithms. You know what I mean? And every time they had to write a program, they had to write sort from scratch. And nowadays, just use std for everything. Okay. So as far as deal or no deal goes, it should be about. Honestly, you could probably do it in about 20 lines of code. I think my solution is 40. So let's take a look at this real fast. So there are the file format for the files. The first line of code is the number of briefcases, and then it's just the value in all the briefcases. So there are 2 briefcases. The first one contains 10. The second one contains 200. If you open up cases, this one is index 0. That one's index 1. So if I open up index 0, then it tells me that briefcase held $10, and then I won $200 because whenever you're down to 1 briefcase, that's it. You win whatever's inside. For a bigger one, cases 3. Like this, then what it's going to do, I need 7. Okay, so let's open up the one that has that one. So it had $2,000 in it. There's $600 on average per briefcase left. So what is this doing? Every time you open up a briefcase, what you're going to do is you are going to compute the average amount of money left in all the briefcases. Okay? And then that's the amount that you offer the person to walk away. You're playing a fair game of deal or no deal. Every time somebody opens a briefcase, then the banker makes an offer that's exactly equal to the average amount of money, rounded down because it's integer math. Okay. So if we were to open up, this one that has only $1 in it, that is briefcase number 8, you'll see the average goes up, right? And if I open up this one, which is index 9, the average goes up. Okay. But if I were to open this one that contains $1,000, that's index 0, 1, 2, 3. It says that one held $1,000. You can see the average goes down. Okay. And so at every point in time, you offer them the average amount remaining. How can you do that with what we did in lab time today? You can accumulate all the values from the vector, and then you can divide by the size of the vector, and that's the average amount. Okay. So that's basically the program. There's some input and output and input testing, and you have to do some file IO kind of stuff. You can either keep playing the game until all the briefcases are open, or you can hit -1 and say I'm going to walk away, and you walk away with $741, whatever the last amount is. You can walk away with that amount. So that's deal or no deal. one thing I should mention is if you're using erase, that's the wrong one. If you're using erase, then this is going to because your vector is going to shrink, right? So this is actually going to screw up your indices. So if like you had 4 briefcases and you open the first one, if you erase it, it actually moves all the briefcases down. So what was briefcase 3 before is now briefcase 2. So you might want to not actually use erase, but might have maybe mark the briefcase as like -1 to indicate it's been opened. And then when you do the averaging, rather than using accumulate, or maybe you just set the value to 0. I don't know. But you just maybe then you just accumulate and you just remember how many briefcases there are left to be open. And so if you accumulate and you get 1,000 and there's 4 briefcases left to be open, then it will say $250. So there's different ways of doing it. With the tools you have now, you have what it takes to do deal or no deal. It's not a hard assignment. You could probably do it in 20-ish lines of code if you were really kind of leaning hard on the standard library stuff. After the RPG assignment, I didn't want to give you something that was like too hard. So this is just a nice, easy assignment. It's due next Wednesday. I would honestly just try and get it done now, and then enjoy the rest of your week. There's a Loops competency exam, and there's Zybooks due on Sunday. But see if you can get this done. I mean, with a lab time today, you should probably make a big dent on it. Okay. So that is it for today, guys. Thanks for coming out, and I will see you next time. Have a great weekend.